Hey there, today we're unpacking a big Martian mystery, one that's literally shaking things up on the red planet. Let's get into it. Mars, our enigmatic neighbor, has fascinated humanity for centuries. From its striking red hue to whispers of water and life, it's a planet that keeps scientists on their toes. Now, thanks to NASA's InSight lander, there's chatter about Mars potentially having a solid inner core, much like Earth. But hold on, before we celebrate this groundbreaking find, let's break it all down. Let's start with the basics. NASA's InSight lander has been stationed on Mars since 2018. Its primary mission? To study the planet's interior structure using seismic activity. Yes, Marsquakes. Think of it as an interplanetary geologist. InSight's ultra-sensitive instruments pick up vibrations traveling through Mars' interior, helping scientists map its composition. It's like an X-ray, but for planets. Recently, researchers analyzing this seismic data proposed something extraordinary. Mars might not just have a liquid outer core, as previously thought, but also a solid inner core. This is huge because, if true, it'd change how we understand the Martian interior and its geologic history. For context, Earth's solid inner core not only contributes to our planet's magnetic field, but also influences tectonic activity and heat distribution, both vital for sustaining life. Could Mars have had similar dynamic processes billions of years ago? Researchers suspect that Mars' solid inner core, if it exists, might be much smaller in comparison to Earth's. The data suggests seismic waves traveled differently through Mars than anticipated, hinting at the presence of a denser, solid structure deep within. To understand this, scientists studied P waves and S waves, two types of seismic waves. P waves can travel through both liquids and solids, while S waves only pass through solids. The detection of S waves hinted at the possibility of solidity within the core. Here's the science in a nutshell. When a quake occurs, seismic waves ripple through the planet. These waves vary depending on the medium they travel through. Liquid outer cores reflect or absorb specific waves, while solid inner cores allow certain waves to pass in unique patterns. By capturing these wave behaviors using the InSight lander's instruments, scientists can construct models of Mars' inner structure. It's an intricate process requiring precision and extensive analysis to differentiate between potential scenarios. But not everyone is convinced. Simon Staller, a seismologist at ETH Zurich who wasn't involved in the study, has called the evidence thin. Now, when a scientist says thin, they mean it's not robust enough to hold up under scrutiny. Think of it as a house of cards, one gust of new data, and the theory might collapse. To understand the skepticism, let's rewind to how seismic studies work. On Earth, we've had centuries of seismic data and thousands of monitoring stations. Mars, it's got one lander, InSight. That's like trying to understand an orchestra's symphony by listening to just the violin section. It's impressive, but it's also limited. Even with InSight's precise instruments, the limited coverage introduces a margin for error that cannot be ignored. Scientists can only infer so much from data that might be influenced by unknown variables, like unexpected material compositions or unknown subsurface structures. Yet, the idea of a solid inner core on Mars is tantalizing. If confirmed, it could solve some Martian riddles. For instance, why did Mars lose its magnetic field billions of years ago? A solid core might have been too small or inactive to sustain the dynamo effect, the process generating a magnetic field. Earth, with its larger, dynamic core and a vigorous convection system, managed to maintain its magnetic shield. Mars' smaller size and its potentially weak or non-existent inner dynamo could explain why the red planet's magnetic field dissipated, leaving its surface exposed to harsh solar winds. This loss significantly impacted its atmosphere and likely its habitability. Now, let's consider the implications for future missions. Understanding Mars' core isn't just academic. It could inform how we search for water, identify safe landing zones, and even plan human colonies. Imagine building habitats on a planet where we've mapped the ground beneath our feet. Knowledge is power, and in space exploration, it's survival. But let's return to the skeptics. Why is the evidence so divisive? Well, seismic waves can be tricky to interpret. Variations in data could stem from Mars' crust or mantle, not its core. It's like hearing an echo and guessing whether it came from a canyon, a cave, or a building. The interpretation depends on assumptions, and assumptions can lead us astray. One key challenge is Mars' relatively quiet seismic activity. Earth's tectonic plates constantly collide, creating a symphony of quakes. Mars, It's more like a solo performance, with occasional tremors. This makes gathering robust data a slow and meticulous process. And then there's the question of peer review. The study proposing Mars' solid core has yet to face the full gauntlet of scientific critique. Until it does, the claims remain provisional. Remember, science thrives on doubt. It's not about proving a theory right, it's about testing it until it breaks, or holds firm. So, where does this leave us? For now, Mars' core remains an enigma wrapped in seismic waves. The InSight mission has given us a tantalizing glimpse, but like any good mystery, it's left us with more questions than answers. And that's the beauty of science. Each discovery is a stepping stone, not a final destination. Before we wrap up, let's consider the broader picture. Why does it matter whether Mars has a solid core? Beyond the scientific curiosity, it's about understanding planetary evolution. By comparing Mars and Earth, we learn why one planet became a cradle for life, while the other became a barren wasteland. These lessons could guide us as we search for life elsewhere in the cosmos. And with that, we'll end today's journey into the depths of Mars. Whether it's solid, liquid, or somewhere in between, Mars' core has sparked a conversation that's far from over. Stay tuned as scientists dig deeper, literally and figuratively. Thank you for watching this video. Don't forget to subscribe, leave a review, and share your thoughts. Until next time, keep looking up and wondering what lies beneath.